All right, so in the last video, we pretty much stopped with the creation of this first byte data type, and we just went through the fact that a byte has 8 bits in it. The byte data type, primitive data type, has 8 bits in it, which is 1 byte. With 8 bits, we can represent 2 to the 8 equals 256 distinct values, and those values go from the range inclusively from -128 to 127, and we demonstrated that. So what we're going to do now is we're going to finish out what are called the whole number data types in this video. So there are 4 different primitive data types that can store whole numbers. Those are the byte, the short, the int, which is short for integer, and long. Okay, so we're going to basically finish out this example by actually doing this one will be a lot quicker. We're going to do some copying and pasting for the rest of this since the general structure of what we're doing is already intact. So what I'm going to do is I'm going to go ahead and I'm going to just copy the chunk of code for this first print basic byte info. So go ahead and copy that, Control C if you will, and then come down here and paste it. Okay, and then we're going to do the same thing down here. Okay, so Control C for the prompt user for input, and then we're going to paste it down here under the short. Okay, and you're going to immediately see that we have a number of errors. So what are these errors saying? If we hover over, you'll see that it says duplicate local variable bmin. Okay, so the problem here is that we have already defined this local variable bmin, and we set it to a value of byte.min value, and then down here we have defined it again. Now we are going to change these, some of these to different variables. So let's actually go ahead and just for starters, I'm going to literally comment out all of this code. Okay, so go ahead and just highlight it all, and then you can right click if you want, source, toggle comment. Okay, or of course the keyboard shortcut is just Control // that'll kind of add those on there. Okay, so let's just focus on the short in isolation, and then we'll go ahead and we'll kind of see what different conflicts that we have. Okay, so we're going to go ahead and update some of our verbiage here in our language. So we are no longer working with the byte data type, we're working with the short data type, so we'll change that. And as you can imagine, I'm no longer dealing with byte data type, so I need to change to a new primitive data type. Okay, so remember, anytime you see purple, you're dealing with this dark bolded purple, you're dealing with a primitive data type and or possibly just a Java keyword. So I'm going to change this to a short. Okay, so we'll just change both of those to shorts. And then, as you can imagine, I no longer want the byte.min value and the byte.max value. I want the short.min value. Okay, so again, short with a lowercase s, notice it bolds it and turns it purple. That's a primitive data type. Short with a capital S gives us this thing called the wrapper class. Okay, so the wrapper class is it's called a wrapper class, W-R-A-P-P-E-R, right? So wrapper class is a class that wraps around a primitive data type. Okay, so and now again, we are very early to start talking about classes. So I don't want you to get lost in this notation class because I really don't want you to consider what a class is at this point. In Java, there's a lot of kind of overhead in terms of language understanding, and that's okay. It's okay to not understand everything right up front. But in short, just think, no pun intended, this short wrapper class right here is something that wraps around this this primitive data type, this value, and gives it some extra functionality. You'll see if I have the short dot over here, nothing really comes up. However, when I had the short wrapper class with the capital S and I typed S, a bunch of objects came up. So anyway, for now, just kind of take it for granted that this you get this functionality when you use this thing called the wrapper class. Okay, so now we have short bmin and bmax, and these are set up with the appropriate values for the shorts. Max and min. Now I'm going to come down here on my num bits and the short is going to have twice as many bits as the byte. Okay, so byte had 8 bits of precision. The short has 16 bits of binary. Okay, so this equation should still work now. I just needed to change the number of bits for the short. Okay, so I'm going to come down here now and again change byte to short in these two places right here. Okay, so the short data type uses to represent negative numbers, and so on and so forth. Okay, so hopefully what we'll see is this math will now just work out simply because I changed the num bits from 8 to 16, and I got the min and max for the short instead of the byte. Now, something else I want to show you, and this is kind of a neat Eclipse trick, is that this variable name no longer makes sense. It says b min and b max. Well, that b stood for byte for a previous example. Now, I really want this to say s min and s max. Well, there's two things I can do, right? I could go and change b min and b max to s min and s max manually. Everywhere you can see it's kind of highlighting all the b min. So I would change it here 1, 2, 3, 4, 5 times, and then I would change b max 1, 2, 3, 4, 5 times. Okay. So I can actually do this much more quickly in Eclipse. I'm going to show you how to do it using just kind of menus, and I'll show you the keyboard shortcut. So for bmin, if I right click on it and then I go down to refactor, okay, you'll see a rename. Okay, now notice up here it says Alt-Shift-R. That's the keyboard shortcut we're going to do in the next iteration. But anyway, so just click rename, and notice now whatever I type here is getting updated everywhere. So super cool shortcut. I'm just going to change it to smin, and then once you've got whatever new variable name you want, just hit enter, and it changes it everywhere. Okay, so I'll do the same thing for bmax, and just recall that this is now going to be, I'll do the keyboard shortcut, which is Alt-Shift-R. Okay, I believe if you're on a Mac, it might be like a little bit different. But if Alt-Shift-R is not working for you on the Mac, then again, just right click, go to refactor, and then rename, and then it'll show you on the Mac exactly what shortcut keys to press. You can see Alt-Shift-R is what worked for us. Okay, so now our code reads a little bit better. I actually have the right proper variable names. It's important that you create variable names that make sense. It'll make your code much more readable. Okay, so now let's see, please enter a whole number within the range, smin to smax, and then down here we'll change this one last line. No longer am I reading in a byte b, I should be reading in short s equals scan dot next, and you'll see there is a next short to read that type of data type in. Okay, and then of course I need to change this b right here to an s. Okay, perfect. So let's go ahead now and give this a play. So you can see the short data type uses 2 bytes, which is 16 bits, to represent negative numbers from negative 32,000 to negative 1, and non-negative numbers from 0 to 32,000. Okay, so thus a short can represent 65,536 distinct values. Okay, now if we just kind of look at this, there's a few things that I don't really like. Okay, so just once we see these 65,536, it's a little bit harder to read that value because it is no comma, right? We're used to seeing like a comma with this 65,000, and it just makes it a little bit harder to read. So what we're going to do is we're going to change our formatters up just a little bit. Okay, now specifically, you can see anywhere where we can start to have these bigger numbers, we want to be able to add the formatter in there. Okay, so that would be basically in these two spots, right, to start off with. So let's give that a try. And what we essentially want to do is we want to stop using this generic formatter. Okay, remember if we hover over printf, you can click on the format string syntax, which will basically take us to the page which shows us exactly what we can do. So we are using this %s, and this basically just formats this data type very generically. Okay, so what we want to start to do is actually say, hey, not only is this some generically formattable item, this number that was printing out, right, the 65,000, but we will actually want to treat it as a decimal integer. Okay, decimal in this case is just meaning not decimal point, but it's meaning decimal as in base 10. So what I can do here is I can actually change these S's to D's, and now it's going to print out exactly the same if I play this. Okay, I'm going to stop it. If I play this, you'll see it'll print out exactly the same, but it's working. Okay, so but what this allows me to do is I can add a little comma right here in between the % and the D, and that essentially what we'll see. Go ahead and stop it. We'll stop all of these. Got a bunch of instances running from a previous. Okay, there we go. Now you'll see it actually will format that, right? So 32,000 with a comma. Okay, so it just makes our code a little bit more readable. So I'm going to go ahead and do that everywhere where I think that a huge number may pop up. So short can represent. So right here, I'm going to change this to comma D, distinct values, and then for this one right here, even though it's this is formatting it as a, if you recall, the F is a decimal number, not a decimal integer, but a decimal number. So that could have decimal points in it. I can do the same thing. I can add the comma there. So let me go ahead and play that, and you'll see everywhere where there's a big number, it is formatting it properly. And we'll see once we start printing out numbers in the hundreds of thousands, millions, and billions, this will work just fine as well. So I'll come and do this on my last, please enter a whole number. So again, just comma D, and then instead of the S, comma D. Okay, so let me hit stop and then clear all these off. Okay, perfect. So now let's give this a try. Okay, so please enter a whole number within the range. So if I give it a number like 500, it prints that out just fine. Okay, I guess I got one more place to do the comma D. Okay, so let's do these three right here. So comma D, instead of S, comma D, instead of S, comma D. Okay, so let's try this again. So I'll do 5,000, and that looks great. Okay, all right, so let's now test out the range here. Okay, so let's go ahead and give it 32,768, or 768, which should be one more, which should just be one greater than this range, this short can represent. And we do see we get that value out of range. And we'll do the same thing, negative 32,769. And we see that's just out of range, whereas negative 32,768 was a valid value that we could store. Okay. All right, so now we are ready. That's the short data type. You can see it stores a much bigger range. The byte was from, I think, negative 127 to 128, so you can see 32,000 much bigger. Okay, so let's go ahead now and move on to the int data type. So again, I'm going to copy this first chunk of code, and I'm going to paste it right here in the print basic int info, and I'm going to copy the print statement right there and paste that down there. Okay, so again, let's go ahead and I'm just going to comment all this out. So Control / and then save it. And let's go ahead and transition all of the short stuff to int. So I'm going to say int data type right there. Okay, I'm going to change short right here to int, short to int, short to, now this is one little difference. Instead of just capital INT dot for the integer wrapper class, we spell out the whole word, so integer dot, and then you'll see you can do the min value and whatnot. So we'll do the same thing here, integer dot max value. Okay, so if we come down, the rest of this looks good, other than I want to change short to int right there. Okay, and hopefully this will all work. So then please enter a whole number within the range. That looks good. So the last thing I need to do again is change my my user input from short s to int I equals scan dot next int. Go ahead and delete that line, and then on this very last range statement, I want to change s to I. Okay, and of course we'll do our renaming trick. So we'll click on s min up here. You can click on it anywhere, so even if you're down here, you can click on it. Alt Shift R. So we'll just delete that S and change it to an I. And then we'll click on Smax and click Alt or type Alt-Shift-R, and then change that Smax to Imax. Okay, so now let's go ahead and see what our range is for the integer. So you can see our range for the integer is much bigger. Okay, so the integer, well, I'm sorry, it's not much bigger because we didn't change one thing. Okay, so we need to also go ahead and change the number of bits here. An integer actually has 32 bits of binary. So now we see, we have a little problem here. Integer can represent 0 distinct values. Something is off right here. So this should say 4 billion distinct values. So let's go ahead and see what's happening right here. I'm actually going to jump into the debugger. This is a good skill. Something doesn't work as expected. Let me go ahead and before I do that, I'm going to clear off any previous examples, and so you can see it can represent 0 distinct values. So let's go ahead and see what happens here. So if I jump in to the debugger, I'm going to set my breakpoint right there and click on the bug. And okay, we're about to print out this value right here. So this very first %d will correspond to, let me go ahead and run one line of code. I'll hit F6 on my keyboard. So for some reason this is printing out 0 when I expect it to print out about 4 billion. Okay, so if I look at this, I'll see Imax has this value right here, 2417. Okay, I'll go ahead and maybe open this up in a notepad or something. Okay, and then the IMin, if you hover over, we'll see is negative. Go ahead and copy that. Okay, so now I have my negative value right there. Okay, and then my 1. Okay, so what I'm going to do is I'm going to open up a calculator and I'm going to see what this adds up to be. Okay, so if I just take this value, so I'm going to paste that in, plus, if you look at our code, what's it doing? Right, it's taking the Imax, which was this value, plus 1, so let's plus 1. Okay. And then plus the absolute value of IMin. Well, here was IMin, so I'm only gonna take the part without the negative, right? So plus, then I'll paste. Maybe I can't paste it, so I'll go ahead and just type it out. Plus 2, 1. Oh, what happened here? Let's go ahead and do this. Go ahead and clear this. Something's off here. Okay, so we'll go ahead and is that plus 1 equals plus 2, 1, 4, doing this one right here. It's 2, 1, 4, 7, 4, 8, 3, 6, 4, 8. Okay, so 2, 1, 4, 7, 4, 8, 3, 6, 4, 8 equals, okay. So we have, if you can see the range here, four 294 967 296. Okay, so you can see we actually have a little bit of a problem here. Okay, so the problem here is actually a little bit of a problem with my source code here. This when I'm printing this out, represents 0 distinct values. So I'm actually computing a number that's bigger than a range. So if you look at this, right, 400 or 4 billion is a bigger number than you can actually compute with integers. Integers, you can only compute numbers up to negative 2 billion and positive 2 billion. So for me to actually try to compute this mathematically, just didn't quite make sense because I'm trying to compute this as an integer. So what I'm actually going to do is I'm just going to reformat this a little bit. So I'm going to say thus an integer can represent, okay, and I will actually just delete this, distinct values. So that way this code should work pretty much as expected. Okay, so this is no longer a floating. We got rid of one of our parameters, so I gotta delete the parameter right there. So now we have the %s here matches to the number of bits, and then the %f here matches to that math.pal computation. So let's go ahead and play that. Okay, perfect. So now we see thus an integer can represent 2 to the 32 equals 4 billion distinct values. Okay, and those values are going to be from -2 billion to +2 billion. Okay, so at this point, it's probably a good idea to go back and we'll just fix our other examples up above where we were printing this out. It's a little bit interesting because you can see above it, it was actually giving us the proper values. It was sometimes things work in Java, even though in programming languages, even though they probably shouldn't. You'll see that the more that you program. So anyway, I'm going to go ahead and up here just kind of fix these. So I'm gonna paste this print statement there, and I'm going to change this to short, and I'm going to go ahead and delete that chunk of code right there, that first parameter. Okay, and I'll do the same thing up here on my byte. Okay, go ahead and delete everything except for the new line character, and I'll paste that, and then I will put a byte in there instead. And then I'll go ahead and I'll delete that very first parameter from the bmax to the bmin. So you should basically have something like this. You get to the new line character with the quote, comma, and then num bits as your first parameter, and then the math.pal as your second parameter. Okay, so let's go ahead now and try this out. So you can see an integer can represent 2 to the 32 equals 4 billion distinct values. And then that is from -2 billion to +2 billion. So if I give it something like 1 million, you can see just fine. Okay, if I give it something like 3 billion, I'm sorry, that was 3 million. Let's do 3 billion. You can see that 3 billion is just a little bit outside of the range of what we can actually represent here. Okay. All right, so sorry, a little bit of live debugging. It's always a good exercise. I'll leave that in there just because it's a perfect example of things don't always go as you'd imagine. It's almost never the case, no matter how long you've been programming, that you just start writing code and it works without issue. So I want to try to do as much live debugging with you guys as possible because it's really one of the greatest skills that you can learn is seeing someone kind of work through a problem as they see it come up. Okay, so let's go ahead one more time. We're going to look at the longs now. Okay, so I'm going to copy and paste the integer code for the basic int info, and then I'm going to copy and paste the prompt user for input as well. Okay, so let's go ahead and comment out the integer code again. So Control / and save that. Okay, so we're almost done here. We're now going to use the long data type, so we'll change that int to long. Same thing right here for these two ints. We're going to say long. Okay. Instead of integer wrapper class, I want to use the long wrapper class. Okay, so we get the min and max values. We'll go ahead and do our Alt-Shift-R right here. So we'll change imin to lmin. And then Alt-Shift-R will change imax to lmax. And long, the number of bits for a long is 64. Okay, so you can basically see it's just doubling every time, right? A byte has 8 bits, short has 16 bits, an integer has 32 bits, and a long has 64 bits. Okay, so now we'll just go ahead and we'll change int to long in our print statement. Okay, and then the last thing I'm going to do is change my input statement to read in a long. So long L equals scan.nextLong. Go ahead and delete that int I line. And then finally on that very last print statement, change that I to L. Okay, so we should now be able to play this. And what you'll see is, if you recall, the integer could read in values from -2 billion to +2 billion. That's quite a big range, right? That's going to handle most of your the problems that you're trying to solve. However, sometimes you need a bigger data type. And what you'll see is the long can hold huge numbers. So the long can represent, I forget it. So this is hundreds of thousands, millions, billions, quadrillions, I think quintillions. I don't even know what this number is, right? Centillions, maybe. It's huge. So 18 something, I mean, this number is exponentially larger than 2 or 4 billion, okay, or 4 billion is what we were looking for. So obviously, I could just type crazy amount of numbers and it's gonna fall. Well, okay, that was a little too crazy. Fairly crazy amount of numbers, and it's gonna easily fall within the range there, right? This is millions, billions, quadrillion. So 45 quadrillion is no problem. You can see I'm well within the range of what I can represent with a long. Okay. All right, so let's go ahead now, and I'm just gonna kind of finish this first part up. I'm gonna go ahead and uncomment all my other code. Okay, so go ahead and highlight all those lines and just hit that Control// again to remove those comments. Or, again, I'll do this again, or if that's not working for some reason, just right click, source, toggle comment. Okay, so I'll go ahead and uncomment all this stuff. Okay, now you'll see there's a few errors in here, and these errors are due to the fact that I define the variable numbits and numbytes up here. When I define it, I have to give it the data type. So I'm saying, hey, numbits is going to hold an integer. And then down here, I define numbits and numbytes again. Okay, so what it's basically complaining about is, hey, you have two variables that are exactly the same name. You need to either rename them or reuse this variable. Okay, and we're going to do the latter. Okay, if I define this variable right here, it is good within the whole scope of the curly braces that it was defined in. Okay, so basically in this main chunk of code right here, this main, it's called a method. Anywhere within this main method, numbits will be what's called in scope. So what I can do to fix this is I can actually just delete this int space right here, and then you'll see all those errors go away. And when I click on numbits, for instance, you'll see it'll in Eclipse, it'll basically highlight everywhere where numbits are. So it's basically saying, hey, these are all the same variables now. So I'm going to do the same thing for my down here in the int section, just delete the int space. And the same thing in the long section, just delete that int space. Okay. So now what's going to happen is on this first section, right, I'm going to define and set numbits to 8, and then I'm going to compute numbytes from that. And then when I get down here, I'm just going to overwrite the values in those two variables, numbits and numbytes, right? Because I no longer need those values of 8 and 1. Now I'm just in a completely different section of my code. I don't need that data anymore, so I'll just overwrite it. So at this point, let's go ahead and run this code. Okay, so I'm going to jump into full screen, and I'm going to run it, and we'll see if it works. Okay, so we'll kind of put it out here. All right, so I'll just give it a value like 55. Okay, the short data type. Now I'm going to do a little bit of modification here just to give this stuff a little bit of breathing room right here. Okay, I always like to give this code some breathing room. So what I'm going to do is I'm actually going to come the last place where we're actually printing out. You can see it's this range. I'm going to go ahead and add 2 new lines. Okay, and then I'm going to do the same thing basically at the end of all these. So I'm going to add 2 new lines just for a little bit of formatting. So / and \n. Okay. Now I'm going to go ahead, double click, and go back to my console. I'm going to go ahead and hit stop. Okay, you always want to make sure that you're only running one instance of your program. Okay, so now again, I'll give it that 55. You see I have a little bit more breathing room here. So give this a few, maybe 5,555. Okay, and then for my int data type, give it a few more. Okay, and for my long data type, a few more. Okay, so the main thing, just kind of in conclusion here, right, we have these 4 data types, these 4 primitive data types that can be used to store any whole number. Okay, we have the byte, which uses 8 bits to store values from -128 to 127. I have the short, which uses 16 bits to store values from about negative 32,000 to positive 32,000. I have the integer, which uses 32 bits to store values from about negative to positive 2 billion. And I have the long data type, which uses 64 bits to store values from about negative 9 something huge number to positive 9 something huge number, right? So we said millions, billions, quadrillions, I don't even know, right? My numbers, my knowledge of numbers is not that great at that high of a level. Okay, but that actually makes the next point that I want to make, which is which one of these data types should you use to store whole numbers? Okay, and the answer, I'll explain this in a little bit, but the answer is typically the integer. Okay. If you think about anything you'd probably want to do, storing, prices for, let's say you're doing like an online store or something like that, right? You could imagine lots of products that you could be selling that were greater than $127, right? So byte data type is very rarely useful. Even the 32,000 is pretty limiting, right? If I'm selling cars or something like that, I can easily have a car 50, 60, 70,000, even $100,000, right? $500,000 if I'm selling a very nice car. Integer data type, you can start to see, hey, 2 billion, that's going to cover most use cases that I have. Almost any program that you can imagine, I mean, that's a little bit of a overstatement, but most programs that you can imagine creating, the numbers that you're going to be storing or manipulating are going to be within that negative 2 to positive 2 billion range. Typically, the only time that I use the long data type to store whole numbers is if I want a unique ID for something. Okay, so think about if I'm doing something where I'm basically going to have a unique ID for every person in the world. Or think about Facebook, for instance, right? Facebook has billions of users on it. So it's feasible that I might have 3 billion users on Facebook, and I need to uniquely identify each one of those with their own unique number. Just like in the United States, for instance, you might get a social security number. In Facebook, you have a unique number that is just useful for you. Now, they may use some different number schemes, but if they wanted to use just a number, you can see that an integer is not going to cut it. I believe back in the day when YouTube was new, there was kind of a story, I don't know if it's true or not, but this is something I heard a long time ago, that they actually had integers to store their data types. I think the story goes that Taylor Swift had like the first video that actually had over 2 billion views, or maybe it was 4 billion, depending on how they represented their numbers. Basically, they overflowed this integer data type, and it went back to like 0 or something like that. So I'm sure that YouTube uses longs in the very least, right? They may use even something more intense than longs, but they at least use longs to represent their view counts now, since there are videos that can maybe have 4 or 5 billion views on it, right? So anyway, long story short, integer data type is usually what you want to use. In some rare cases, you'll use long. These other data types exist mostly for storage purposes, like you saw here. As we do go, into down this string right here, the data types are taking up more memory. The general conclusion today is that we have so much memory in our computers that we really just don't care about how much memory we're taking up. I mean, we have gigabytes of RAM, terabytes of storage on our hard drive. Back in the day when you maybe had a few kilobytes of memory in your computer, back in the 60s, 70s or whatever, you really would want to think about, well, will I have a number, if my numbers are only, maybe I'm only storing ages of people, right? Well, let's use the byte data type, because surely no one will ever make it to 128 years old, right? Now, we just don't think about that. We have so much memory, even if we're storing ages and we know no one's going to be 128 years old. Hey, let's just use int, because it's just easier to kind of have code that just uses one of these primitive data types for whole numbers. Okay, so we're going to do a pause there, and in the next video, we're going to continue on and take a look at the decimal point number types.